What's up, people? Back with another video. I'm going to do test prep. We're continuing test prep. We're gonna do 2017. Let me just check what it is. Yeah, so prep test 1 2017. That's what my title says. Okay, so test prep 2017 test 1. Right, so 90 minutes to complete this. We're going to try and take less than that. Yeah, you'll read the instructions. Okay, in mathematics, the general form of a second order polynomial quadratic equation is ax squared plus bx plus c equals 0. The roots of equation 1 are given by, okay, they give us the quadratic formula. It tells us about the discriminant. If it's positive, it will have positive real roots, and if it's negative, it will have imaginary roots. The discriminant is 0, there is one repeated real root given by that, and then you are required to write a computer program in C++ that will solve for the roots of a number of quadratic equations is specified as a list of coefficients in an input file. Okay, your program must comply with the following specifications and requirements. Okay, you're going to read in ABC from input.txt. There'll be spaces in between each, so you can read in. The number of lines is unspecified. The solution to the roots of each quadratic must be written. Output file. The roots must be separated by spaces. Note that the number of lines in the output text file must be equal to the number of lines in the input text file. Okay, all numbers in output text must be recorded. Okay, 3 decimal places. Double or distinct roots must be repeated. Cool. Non-real roots must be written in the form x plus jy. The program must run without any console inputs from the user and must not produce any console outputs. Okay. For simplicity, you may ignore the special case when a is 0. For bonus marks, once you have the other cases working, you may include this case. Alright, let's get into it. So they gave us an example of 5 quadratic equations. I'm quickly going to go to my desktop or wherever my main is and put in those 5 quadratic equations into my input.txt. So when you want to put these in, you're going to put it in like that gray rectangular box. So it's going to be 1 space minus 2 space minus 3. Yeah, don't put in the x squared and the x and equals 0. Don't put all that. So 1 1 minus 4, second line. Then we have 1 2 1. Then we have 1 1 0.5. Then we have 1 0 0.5. Okay, just gonna save that. Alright, my input file is ready and let's begin to code. Okay, first things first, include your libraries that you're going to use. Okay, for now I'm just going to include the file, the F stream for reading and writing to files. Okay, I'm going to create an object called input file of type ifstream. I'm going to use the object to open the file where I've recorded all the input values, called input.txt. Don't forget your semicolons. Right, Since we're dealing with the quadratic formula, you're gonna need three variables. You're gonna need um, let's use doubles because our inputs are not purely integers, and our outputs look like they are fixed to three decimal places. So we could use floats as well because they give you single precision, which is three uh, points, but I'm going to use a double just so it's more accurate. Okay, double A. And in this video, I'm going to teach you how to initialize multiple variables of the same data type. So if I have three variables that are doubles and I want to initialize them all to 0, I just put what value I want them to hold in brackets next to their name. Can you see that? So I initialized A and I put its value within these round brackets, comma, and then B is my second variable, then C is my third. Cool. I'm also going to create let me put it here as well. So I'm going to create the variable I'm going to use to store like the roots. So by roots I mean the x values, right? So I'm just going to call it x roots like that. I don't know if I'm going to need more than one, but for now I'm just going to leave one there. Okay, so always remember, if you have more than one line in your input file, or you're not told how many lines there are, which we're not told how many lines there are, you're always gonna have to use your object, use a while loop and keep reading in and performing operations within that loop. This is the way I do it. You might use other loops, whatever, like a do while with some condition maybe within the loop that breaks when it's met or something. I don't know. Right, so now we are going to code for the quadratic formula, right? And it's x is equals to minus b plus minus square root of b squared minus 4ac over 2a. But remember, there's special conditions that we need to deal with. I just want to see what happens when I square root. I'm going to include CMath so I can use the square root function that's built into the CMath library. Okay, when I square root a negative number, I want to see what actually pops up in C++. Oh, that's so long. Okay, so can you see that it's like not a number, not a number, not a number. So when we have a discriminant that's negative, C++ is just gonna say no, this is not a number. Okay, so we need to have special conditions, or we need to perform um, uh, we need to perform some calculation to determine the discriminant, and from that it will lead us to other conditions. So we need to try and we need to let me just do it right. What I want to say is that if we have a negative value under the discriminant, we're gonna need to have some type of if statement, for example, and in that if statement we're gonna change the number to positive, and then when we're displaying, we just know that we need to put a j next to this number, because that's the only way we can show a non-real or imaginary root in the code. Okay. Right. So I'm gonna make another variable, also gonna be a double, so I'll put it in line here. I'm gonna call it the discriminant is the full name, but in C++ you need to name it some easier way, not writing it out fully. I mean, you can't have long variable names, right? So I'm gonna call it dis for discriminant and calc for calculation. I'm gonna initialize that to 0 as well. Cool. So I bring in from my input file from the first line a variable for A, for B, and for C, right? And now I'm trying to determine the roots. But before I do that, okay, in the brief we get three conditions, right? So it's like if it's positive, there's two possible situations that come out. If it's 0, there's only one, and if it's negative, there's also two. Okay, so let's I don't know if you're comfortable with functions yet. I want to use functions in this test, so I'll show you how to make functions now. Okay, so I bring in, boom, A, B, and C. Then I'm like, okay, let me do my discriminant calculation, right? Because that will make me branch out into the conditions. If I find that this discriminant calculation is positive, I know that there's two cases that are coming out. If it's negative, there's two cases, and if it's 0, then there's that one case which is just minus b over 2a. So your discriminant calculation, remember, it's this. Okay, another thing, we're working out the b squared minus 4ac, right? We're not going to square root it yet because that'll give us not a number, which is not what we want. Alright, so using power from CMath, which is a way of squaring or raising a number or variable to a certain power. And in this case, we have b squared minus 4 times a times c. Okay, so this is my discriminant calculation. Right, now I'm going to have my conditions. So the first one would be if the discriminant calculation is not greater than, is, actually, yeah, is greater than 0. Any number greater than 0 is positive, right? If it's greater than 0, I'm just going to use comments now so that I don't get errors in my code. Good way of planning. I'm going to say make, go to function dealing with positive this calc, full stop. Then I'm going to have else if the discriminant calc is equals to 0. Remember, that's the case where we have only one possible solution, and that is that the x roots is gonna equal to minus b over, I'm gonna use brackets because I'm performing a mathematical calculation before I divide, right? So my x roots, which is x, is gonna equals to that straight. Cool. If or else, I don't know. there's only three possible cases, right? It either gives me a 0, a positive or negative number. So I'm gonna just put else because that's the only thing that's left. You can also write else if, but I don't know what you're gonna put in your else statement. Maybe there's an error in your code, maybe you're not reading incorrectly or something. Yeah, okay, cool. So for this one, remember what's gonna happen is that our x root um okay, yeah, okay. See, when we have a non-real root, right, you know that we have a real part plus j times imaginary part, or is it that? Yeah, something like that. Okay, so even in this calculation we're going to need to break up we need to do the real part and do the imaginary part separately. Okay, so in my variables I'm going to create another one called x uh, roots oh wait okay, we're going to call it x j roots. Why do I put the j? I put the j because non-real numbers are normally, imaginary numbers normally have a j or an I with it. Yeah, so that's why I put it there. Cool. Now I'm going to go to function dealing with negative discalc. Okay, these comments, right, are just for me to understand what I need to do while I'm in the test. So when I submit my work, I'm gonna remove these because remember what I said in my previous video when we did the lab, I think it was lab 2, that when you write comments, you write correct. You explain why you're doing this in your code and not what you're actually doing. So can you see this code tells me that I'm going to the function? It doesn't tell me why I'm going to the function. It just says, yeah, go to the function. So that's not a good comment if someone's trying to understand your code or mark your code. Cool. I'm also going to put brackets here because it just helps me organize. Right. If you look at your test question paper, right, do you see that the real part of a complex root, so that's in the case when we deal with a negative uh, discriminant, right? The real part is just this calculation here. So what I'm going to do is I'm actually going to put this as well in a function so that I can use that function again if I have to do a calculation for this guy here. So that's your first. I'm sorry about my neighbors. That's the first one of the rules when you're dealing with functions. You want to make a function of something that you're going to use multiple times. This helps you save space, time, and commit less errors because if you make an error in your main where you repeated code multiple times, the same kind of code, and you find that you made an error, when you debug, you have to actually change it in each and every place where you implemented that equation or a variable that was wrong. Whereas in a function, you use that function multiple times, so you just need to go to the uh, the code of the function. So like uh, int main is a function. It's just that code blocks has this as default, meaning that this is what it runs by default, right? And then we make functions and use them in main. So I'm going to right here go to function dealing with zero this calculation, full stop. Right, let's make those functions. So for the positive one, I'm gonna say, oh, okay, cool. When we return the functions, right, look at main. Main has what? Int in front of it, so it's int main. Int represents the what type of variable or data value this function is returning. Int main returns 0. If I scroll down, you see that we put in return 0 there, right? That's because main is an int. Okay, so in the case of dealing with or doing a calculation for roots, look, our root variable in main is a double, right? So when I make my function, I'm going to make it return a double. Okay, so double, now I'm going to name the function. So this is a positive x roots. Or you can be like, yeah, positive x roots calculation, right? That's a bit long for a function name, but for now we do it like that. So in int main, we normally leave this thingy blank. This is called no, I don't know what it's called, but that's where you normally put your parameters. Okay, so whenever you use a function, you give it parameters that you maybe got from your main that you want to use in there. So in the case of me dealing with this positive, this positive what's this thing called, discriminant calculation, right? I'm gonna need what to perform the calculation. Look in your test question paper. You're gonna need B, you're gonna need A, and you're gonna need the discriminant, right? So I'm going to need a double. So you have to give the name of each variable. I mean the type of the variable, then the name. The name doesn't have to match here, okay, because you're not dealing inside main. So this function has nothing to do with main at the moment until we link it up. So I can name this anything I want as long as I know what it stands for and where I'm using it. Okay, so it's a double. I'm gonna call it A to avoid confusion. Double. So like I created and initialized these variables on one line because they were all doubles and I didn't want to write double 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 all the time, so I used this way of initializing. It works and it's allowed, but when it comes to functions and putting in parameters, you have to separate them and you cannot initialize them in the in these round brackets of the function. Yeah, all right. A, I need B. I'm going to need C because remember, oh no, I don't need C because I'm getting the discriminant from here, right? I mean from here, okay? So I don't need that again. I'm just going to square root the discriminant inside. So I need A and B only. Cool. And that's how you define, oh, no, that's how you declare a function. So I'm not only going to declare, when I put a semicolon, I declare. I'm not only going to declare, but I'm also going to give it a definition as well. So that means I'm going to write code as to what I want this function to do when I feed it in two parameters A and B in these places. Okay, so I'm going to create right, it needs a return. Okay, so I'm going to, oh, sorry, I need to put a comma there. I'm going to create a variable also called x roots. It has nothing to do with this one. That's why I can name it the same. Okay, it's like completely two different functions. Right now they're not related. It's like I'm creating a skeleton over there. Okay, so I can call it the same thing. So okay, so they're two distinct um, roots that are given. Wow. Okay, I'm going to have to do some special stuff, and it's gonna take time to explain. Okay, cool. What I'm going to do, I'll put it down here so you don't get confused, right? Uh, I have a variable for x roots, okay? Yeah, let me just do it in the same line. I have x roots, okay? I'm going to call it x roots 1. And why I do that is because there's two distinct roots that come out from a positive calculation, okay? So I'm gonna make another one called x roots 2. I'm also going to initialize that to 0. Okay, and now I'm going to teach you how to uh, pass by reference. Say yay! So when you pass by value, which is what I'm doing here, it's saying that a gets a value, and if I call the function positive blah blah blah, and in these brackets I put a b, sorry, it takes the value of a and b from here with the same function name as this guy and puts the values in here. So it makes copies of those values. Okay, but what happens when you pass by uh, reference is, and you show by reference with the ampersand sign. And what that does is that instead of making a copy of the variable, it goes to the address of where in memory where you've stored the variable. So if I pass in x roots 1, wherever the IDE created x roots 1, okay, that's a block of memory with an address, right? This goes to the same address and then alters whatever changes are made. It's like, yeah, it does changes to this part. If I use a from main in here and I say a plus plus or a is now equal to 2, once this second curly brace is closed, the value of a or the copy I made here does not affect this in any way. Like even this block of memory that was used, it gets erased. It's like, yeah, you're done with this block of memory, you did some operation. Now whatever was reserved to A is now erased. Okay, and I'm sure you all did that in some school or something. Yeah, stack and heap and stuff. Right, so why I decided to, I'll tell you why I made that for you. Why I decided to pass by reference is because when in int main you can only return one integer, which is that return 0. Okay, even the functions that I declare and I make, I cannot return more than one uh, value, or yeah, one value. So this allows me to directly affect two variables at once, and that's what I want to do in this function. I want to create, or I want to perform calculations for two positive distinct roots. Okay, and those two are going to look like this. So for my first one, x roots 1, that's gonna equals to, and I'm reading now straight from the thingy. Yeah, wait. I also need to put in another double, which will be the discriminant calculation. Cool. I hope you're not lost. Cool. So x roots, I'm now gonna read straight. So I'm gonna use brackets because I'm doing a division within this calculation. So it's minus b, which I'm bringing in over here, right? Plus, use the square root from CMath, the square root function. It also has parameters. What's inside? Remember, we square root what? The discriminant, which is that. And then we are dividing the entire thing by 2 times a. I'm going to put the 2 times a also in brackets because it needs to perform that calculation before doing the division. Alright, so that's one root. So what this does is that it says, okay, x roots 1. Cool. You're there, you're being passed by reference. That means at the address where you created this variable, okay, I am going to change it directly. So I'm changing the value at x roots 1. Cool. Remember to put a semicolon. The second one, x roots 2 is going to equals to the same thing, minus b. Remember now it's not a plus, it's a minus square root. This is what makes up your two distinct positive real roots. 2 times a semicolon. Cool. So you're done with the case. Okay, wait, we're not done. You're done making the function. Okay. Alright. Void. Why do we use void? Void is a data type that it's a data type used for functions and it has no return. So like, void in space, or space is void, there's no oxygen there, there's no, do we say there's no air? But you know what I mean, vacuum, void, we say there's nothing there. So void in C++ means that this function has no return type. Can you see there's no error popping up telling me that I don't have a return, blah blah blah? That's because void returns no value. Cool. And you use void if you're going to work with variables being passed by reference, or in this specific case I am. Maybe you want to pass by reference and return something, then you would change that to be whatever data type or value you want to return. Okay. Now, I have made my function for positive x roots, okay, but I have not somehow incorporated it into my main function. Okay, so in int main, I'm going to remove the comment where I'm supposed to be doing a calculation for the positive x roots, and what I'm going to do is call the name of the function positive pause and then x roots. Cool. Can you see that it shows me that I need to put in parameters for all these variables, right? I have a from my input file, I have b from my input file. I'm performing a discriminant calculation here above, so I'm going to use that result called discriminant calculation. I have a variable that I declared called x roots 1, so I'm going to use x roots 1. Okay, I have another one called x roots 2. Okay, that looks nice and neat. Right, now another thing I want to address is that when you are creating the function, can you see you declared the data types for each variable within your function definition or declaration, right? But since in main we've already told the IDE what these variables are, they're all doubles, right? You don't need to again specify that these are doubles. It already knows that, okay, these are doubles, okay? And just by putting in the numbers I want in the function, it will perform the calculation for me. So let's say I run the code, it comes here, it's like, okay, create an input file, object, open the input.txt, create these variables, read in from the file, perform this discriminant calculation, and then it has this if statement. So it's like, if this calculation is positive, greater than 0, then go to this function, right? So it jumps up here, it's like, okay, I have all my parameters, I come here, I perform my calculations, then I come back. So when it comes back, remember you have two variables being passed by reference. So x roots 1 is no more 0. What is it going to be? It's going to be this here, this calculation here. X roots 2 is going to be this calculation here. And it's going to store those. So let's say in here I was like, a is now equals to 7, and I do that. It is not going to affect this a at all. It has no relation with this a at all. So I just wanted to make that clear and for you all to understand. That's because a is not being passed by reference. It's just a copy of this a, which is the a you're reading in from the input file. Cool. So let's continue. Now we need to make this one here. This one is a bit easier because it's going to be easier because it's one repeated real root. It's not two distinct real roots. So I'm going to make a void function again. I know I'm returning one. I'm only returning one data value for one root, but I'm using void because if you read for your output, you need to display this root twice, and it will be easy for me to make a general case where I display x roots 1 and x roots 2 instead of saying or having another condition below saying it, if this discriminant calculation was 0, then display the answer twice. Okay, so that's why I'm just gonna display it once. So I'm gonna call this one 0x roots calculation. Double, let's see, what do we need for this one? We need b and a only. Okay, so double a, double b. Okay, but remember you're using the x roots variables that are being passed by reference. Okay, so you need to include them in your function parameter. X roots 2. Cool. And then how do we perform the calculation? So x roots 1 is gonna equals to minus b over 2 times a and x roots 2 is gonna equals to x roots 1, right? Because remember we only have one repeated root, so that just makes my calculation easier. I want to have the same answer being shown twice. Now this is an if statement, right? So it means that it's only going to perform this calculation if it gets a positive value. Here we go. Just remove this comment. 0 x roots calculation. I'm putting in a b. Come on. Putting in a b x roots 1 x roots 2. Done. Cool. Now let's deal with the last one. So this is for negative values, right? So for the negative one, we're going to need the same things, a, b, and the discriminant calculation. So I'm pretty much just going to copy this because I need the same parameters. Just gonna make things easier. Copy. Just make sure I copy that properly. Okay, cool. Void. Paste. Paste. Ooh, actually this one's gonna have more, but anyway, I'll discuss that now. So this one is gonna be negative x roots calculation. Let's see if I named that right. Nope. Oh no. Let's be consistent with naming. X root calc. Cool. Okay. Why are you giving me an error? Oh, okay. You want some brackets. Are you happy now? Okay. Look at your formula, right? You have minus b over 2a, which is the same, right? And remember what I said, where you're going to get that result from. You're going to get it from this guy. Yeah, okay. So let me just remove this because this function is going to use another function. Okay, just like how in main, the function, you are using other functions, okay? For the negative function, the calculation, I'm going to use this function, okay? And why am I going to use this function? Because I want to have the what's this? The minus b over 2a, which is the same for both distinct non-real roots. Okay, so let's first do the ones. Okay, so I'm going to bring in a double, and I'm going to call this double my 0, or I can call it, yeah, let's just call it the 0 roots. I should call it the positive root. Is it going to confuse? Let's stick with 0 root, although that name is just, it doesn't make sense. It's not the 0 root, it's the positive root. It's the positive part of the complex root, okay? And then I'm going to have the negative part, which is the negative discriminant over 2a, okay? So I'm going to bring in the discriminant calculation in there. And what else do I need? That's all. Cool. Yeah. Okay. Now, first things first. I'm not done yet. So since I used x roots 1 and x roots 2 here, which are going to be my minus b over 2a calculations, right? I'm going to include them. Oh, wait. Is there an easier way of doing this? No, these ones are going to change it for me. Okay. So do I need to change them in here? No. I just need to call this function in main. Cool. Okay. So for this one, all I'm going to do in here is display yeah, okay. So in here, what I'm going to do is I'm going to take the discriminant calculation. Sorry, I keep forgetting to put a comma and putting semicolon. And I'm going to say that you're going to take the one you brought in, which is in that place, right? And then I'm going to multiply it by minus 1. Why am I doing that? Because I want it to be positive. Another way of doing it is to say absolute absolute value of that. What is it going to do? It's going to make it positive, right? So I've made it positive. Okay, now I still need to do the square root of it over 2a. Okay, and I'm gonna call, I need to change what I've written here. What is positive root gonna bring in? Do I even need that? No, I don't. But I do need a. Okay, so right now I'm gonna, for the minus b over 2a part, I'm gonna use this function because I have it already, so I don't need to repeat it. Okay, and then for the negative part, I'm going to make my discriminant positive. I'm then going to use this xj roots, right? So I'm going to make another variable here and pass it by reference called xj roots. Okay, and why is it my xj roots? Because this one is a non-real root and it has a j in it. Cool. I do that and I say xj roots is gonna equals to the square root of the discriminant calculation over bracket 2 times a close bracket semicolon. So for the positive part, I have to call what? The 0 x roots and put it in a, b, x roots 1, x roots 2. That gives me my positive part, right? Which is the same for both. X root 1, x root 2 are the same with a and b. I'm just going to check if it matches my function definition. A, b, x root 1, x root 2, good. And then I'm going to perform the negative x roots calculation, and I'm going to insert a, I'm going to insert my discriminant calculation, and I'm going to insert xj roots semicolon. Cool. So basically you're done with calculations. Okay, we can test the code, but so far I believe that everything I've done is correct. So what I like to do is, instead of taking it straight to the output file, I like doing a cout to see what's coming out, and I'm going to try and put it in the format like we have for the output text, right? So if you have two positive roots, what do you think you're going to display? You're going to see out your x roots 1, which, and leave a space and show me what your x roots 2 is, because you have two distinct roots, right? I'm going to create an inline there for your 0 roots. Okay, and this is why it makes it easier for me, because x roots 1 is equals to x roots 2 for this part. I can just display them both instead of repeating x roots 1 twice or something, which would also be fine. And then for this one now, it's not just straightforward as the other two. You need to try and manipulate it a bit. So you're going to display x roots 1. and then you're going to display a plus sign, and then you're going to display J, and then you're going to display your xj roots part, and then you're going to leave a space, and then you're going to display x roots 2, which is the same as x roots 1. Oh, I made a mistake. It's supposed to be minus b over 2a. Oh no, I'm using the same formula. I mean the same function, sorry, I've done it there. And instead of a plus in this one, you have minus j, and then you're gonna display your xj roots, and then end line, right? Done. Okay. So what I'm expecting to see is that for each line in my input file, I want to see the outputs that should match the results here in the test paper. Okay, so I'm going to run this quickly. Cool, let's see if those match. Minus 3, 3 minus 1, 1.56155, minus 256,155, minus 1, right, 5. Whoa. Okay, it seems like, can you see for the fourth one in the paper, it's like it got them mixed. It displays the negative one, then the positive one, and the one below that displays the positive one, then the negative one. Did I make a mistake? Minus, plus, minus, plus, minus. I'm quickly gonna check my input file to see if I didn't mix things up. Okay. Everything seems fine.